Welcome to Design at Large. I'm Jim Holland, and Haijun and I have been coordinating Design at Large this quarter. The theme is AI in the new information age. Brian is our TA, and if you're taking this for credit, you need to fill out the usual form. And if you have any problems with that or anything in life, talk to Brian. Navardo has been assisting. Where is Navardo? He's back there. He's been assisting, he and Matthew, with AV this quarter. And this is our last meeting of the quarter. So I wanted to thank Brian and Navardo and Matthew for all of their help. Oh, okay. Yeah. And hands. Good. Okay, it's somewhat special for me to introduce Dan Russell. It's always nice to interview people that you know. And I've known Dan for 40 years. And so...
We were in the same daycare, so just so you know.
And I think I first met Dan at the legendary Xerox PARC back in the days of list machines, and the first wave of AI that was happening at that time. Dan did his undergraduate degree at UCI, a little bit north of us, and then he did his PhD at the University of Rochester. And I think I could get the series of his employments right. The first place he was employed was Xerox PARC. Yep. Then he moved to Apple. Then he went back to Xerox. Then he moved to IBM.
Right.
And I think for almost the last 20 years, he's been at Google.
Right.
There
was a little startup in there.
Yeah. Sorry, I just ruined your presentation.
It's okay. I got it.
So Dan's always been interested in understanding people in the interaction with technology, specifically sense making. How people search and how to improve the way people search. I highly recommend his book, The Joy of Search, and another book coming out in the not too distant future. And I warn you though to avoid his blog, Search Research. If you don't have time to get engrossed by one of his tantalizing search challenges. I think there's no single individual in the world who has taught more people about how to search effectively, and even more importantly, how to judge the trustworthiness of search results and information. In these days of large language models, hallucinations, and deep fakes, understanding how to validate and trust information is one of the most crucial issues of our time. So please join me in welcoming Dan to tell us about 40 years of chasing users.
Okay. Thank you, Jim. It was somewhat of a surprise when Jim asked me to come talk, and realizing that it, in fact, has been 40 years, not only since we've known each other, but since I've been actually studying people using complex systems. In particular, my focus has been on AI and how people understand these things that we build, because we can build immensely complicated systems. Good luck understanding them. So let me tell you a little bit about me. So I'm a cyber, tribal, techno-cognitive anthropologist, which means that I really think carefully about how people understand and use technology, in particular, technology of search. And this has been more generally within this concept, this field of AI. How do people use and understand AI systems? I also have a kind of checkered past. I have written big AI systems as an engineer. I've done research now for a long time, and I teach. I bet you couldn't tell that. So let's start off at the beginning and think about AI and user models. And by that I mean, a user model is the way the system thinks about you. We'll get to the other in just a minute. But how does the system understand you, the user? And to cast your mind back a little bit, you probably remember 1982. The computer was on the cover of Time magazine. And 1982 was also the year that CD-ROMs first came out as a technology. Not as digital technology, mind you, as audio technology. It took another year before you could actually load a CD and download the AOL spamware onto your laptop. It took a year for that to happen. So 1982, I was at Xerox PARC, as Jim said, and my job was, as a newly minted PhD, was to help Richard Fikes to build the Bluebonnet system, which was basically a system that would help people use this big fancy copier. And the default copier UI at the time was that. Like, all UX people should look at that and think, this is the Antichrist. This is not the way you want to design something. So we spent a lot of time trying to build an AI system that would help people use this complex device. Now, the way Richard built the underlying planning system was to do theorem proving. Now, this is back in an age when AI was real AI. It was Lisp-based programming. So it had lots of parentheses, and this is back in the day when programmers used Lisp to build AI systems. And we would do this, and so we had this system that we knew worked really, really well. We knew that if you specified the goal, it would create a correct plan. It was provably correct. It wasn't any of this LLM stuff. It was provably correct. No hallucinations guaranteed. So at the time, Lucy Suchman came to me and said, hey, Dan, I know what we should do. We should do a usability study of the system you built. And I said, as an AI guy, what's a usability study? And so she said, well, what we'll do is we'll give people a set of tasks to do with your AI system, and we'll videotape them, and we'll watch them use it. Sure, what could go wrong? So we did this, and basically this is my mock-up, because I don't have a screen grab from 1982. You would specify a goal in the top. I want double-sided copies, paper inserts, blah, blah, blah. You specify the whole thing up there, and then say, create. And we put a big green button up there. Create the plan, and the system would then generate a multi-step plan, and if you walked through it correctly, it would do what you asked. It would create the plan to execute the goal you wanted to achieve. Straightforward, right? Yeah, that's what I thought. We had person after person come in and fail at the task, which is why Lucy Suchman's chapter 6 of that thesis work was basically our failure. I tried really hard. I built a 3D animated graphical package so we could have interactive animated models of this copier, and it didn't matter. And I said to Lucy, we need better users. So,
You already had Alan Newell.
well, funny you say that. There's Alan Newell. So we got, in this particular test case, we had Alan Newell and Ron Kaplan, arguably very, very, very smart people. And they failed in exactly the same way. And I thought, what am I doing wrong here? And that was my Saul on the road to Ephesus epiphany. I realized maybe it wasn't them, maybe it was me. Maybe I'm a crappy designer. Maybe I don't know how to communicate what the AI systems want you, the human, to do. So that was an important moment for me. And that's when I switched to HDI. I didn't ever drop AI. I kept doing AI for the rest of my life, the rest of my career. But I realized I needed to understand how people look at these systems and use them. And I have my first observation about AI systems, which is poor UX blocks good AI. You might think that AI system will survive terrible UI, and you would be wrong. This is a great example of that. And there are many, many, many examples that you can find right now. It doesn't take very long to do searches online to find really terrible AI products. So what was interesting about Bluebonnet, about that system, was it had a user model. And the user model is based on sensing, it's based on how we interpret user behaviors, how we track people's language use, and we would create these explicit models of behavior in whatever they were doing. And right after we did Bluebonnet, I built a system called the IDE interpreter, which is basically a fancy AI tutoring system. Now, this should look to you like a knowledge graph, because in 1983, this was a knowledge graph. It has exactly the same properties as knowledge graphs you know and love today. So we built this thing, and we would then infer the user model based on what people could do or not. And this is very much at the same time and same kind of zeitgeist as Jim and Steamer were building at around that same time. Build AI systems to help you learn by tracking what you knew and didn't know at the time. So we would do things like, did you correctly perform this function? And we would then even model forgetting. So you don't remember things forever, do you? So this should not be a surprise to you, because it's very much like what the Khan Academy has in their model of student right now. Giant knowledge graph, a little check mark next to the ones you know and the ones you don't know. So if you've exhibited the carry 1 when you do multiplication into the next column, check, and we track your knowledge that way. So what's interesting about a lot of AI systems today is that they're missing all kinds of stuff, like a model of what the student knows and doesn't know, right? This is an area of research, but there's a lot of history to go on here. Also, a lot of AI systems today do not understand, for example, your affective state. Are you really mad like this guy? Makes a difference. It makes a difference both in the way you tell the user what they should be knowing and the way that they will interpret what they hear you say. We don't understand the history of the user or how sophisticated they are. We don't understand their linguistic register. That is, what language should we use to communicate with you? In an LLM, that's not an input, right? So what I'm interested in is how people understand the AI systems we've built. So I'm going to show you a few examples of failures. This is a failure from not very long ago where I go to Google Maps and it says, oh, by the way, you need to go check in at Comfort Suites in UC Davis today. But Google Maps doesn't know that I canceled yesterday by phone, right? Building AI systems requires understanding the context, what we used to call the frame problem. The frame problem, for people who not in AI in the 80s, was basically all the other stuff you needed to know that changed or didn't change when you took an action in the world. In this case, my favorite Google doesn't know that I called him up by hand on a phone and said, forget about it. So it's telling me twice that I need to check in. Or this is a calendar alert that popped up on my phone at work the other day. This is a couple months ago. It said, oh, by the way, you need to leave now to go to Bodega Bay. Bodega Bay is a city just north of San Francisco. It's about 2 hours and 11 minutes north of San Francisco. I wasn't going to Bodega Bay. We have a conference room also named Bodega Day. There's a type problem here, right? Conference room, city. I don't know, which should I use? So what's funny about it is that later on, at 1 p.m., it's going to hold a seat at Bodega Bay, but I don't know what that means. You see what's happening here? Frame problem, understanding what context gets shared, what doesn't. So let's talk about, that was user models. Let's talk about mental models. That is how you, the person, think about the computer, the system, the AI. What do we know? I'll tell you a couple of things. First off, there are lots of effects that we know about how people think about systems. So we know, for example, there are forgetting effects and remembering effects, and there's something called positive transfer. There's also negative transfer, but we'll leave that out of the equation. Positive transfer is when you use a system, and then you switch to another system, another part of the system, and what you've learned over there transfers positively to over here, okay? So we know that when you use this kind of controller, you use that kind of controller, you don't have to relearn everything. Negative transfer would be, for instance, if a car maker decided to move the position of the gas pedal and the brake for those cars in the UK. They don't do that because they want positive transfer. If they did do the mirror image, which would be completely rational, if they did it, they would be killing thousands of people. Every US tourist who went to the UK would die within the first 5 minutes. That would be negative transfer. So Positive transfer, if we think about my favorite AI system, we talk about positive transfer example here. I've searched for Oslag, the name. Notice that the A has a little ring over the top of it. So in Swedish, that's the ring or the halo A character. So what happens is you get these very nice results, all using the correct character. Now suppose I type in that same name without the ring character, and it gives me, logically, different results. Okay, it gives me something about a TV show and an Oslag there. Now, let's open up one of those pages, and now I'm going to search using Command F, Control F, for Oslag right here with the ring A. What do you find? The text find matches all these non-ring A characters. So what's going on? The find function works differently than the search function. Okay, I can deal with that, whatever. Okay, well, let's go and look inside of Google Docs, and I type ring A. Wait, this is the Google product, right? It matches the non-ring A characters. So the Google product differs from search to Docs. It does not have positive transfer. Okay, so let's check out something else. Let's check out Microsoft Word. I type ring A character, and it doesn't match. That's the correct behavior. You didn't type capital A, you typed ring A, which means that find works differently every single app. There's no transfer going on here. You may not care about that. Let me show you a different example. This is Google Drive. I've done this search up here. It looks for owner and a particular document type. I got one document. I think to myself, you know, I thought there were more documents than that. Now, what's interesting is if you do that same search, but do not hit enter, it shows you 1, 2, 3, 4, 5 documents. What? If you don't hit enter, you get more documents than if you hit enter. What's happening is there are two search systems running. And there's the one that gives you the pre-enter results and the one that gives you the post-enter results. I would argue this is a bad design, right? But it's not a positive one. Let's think about spell checking, because spell checking is the AI system everybody used first, right? You type in a sentence like this, they're thinking it's their ball, why can't the driver? So it puts the underline under there because it realizes in the context that this is the wrong there. I want T-H-E-I-R, not that one, right? Or can't, that's actually a legitimate English word, just not the right one. So you get this correction offered to you, and it's, yeah, okay, I'll take it. It's correcting it correctly. Good job. Now, the reason I'm bringing this up is because the function of AI systems, like, say, search in that, or in this case, image search. A couple of years ago, you could go to your Google Docs, Google Photos, or in my case, my Google Photos, and say, I want to see pictures of my cat. Voila, brilliant. It has done item classification. It returned all of the images of my cat. Now, what's interesting about this is I did this just last week, a couple weeks ago, and I got one result. I have not deleted any photos. What went wrong? The back end changed. The AI system changed. So here's an interesting AI design problem for you. How do you design a system when the behavior can change daily? Have you ever seen this happen? I've just shown you 3 different examples of this happening, where you get one set of results one day and what is a different set of results on the next day. How do we deal with this? More generally, what I'm interested in is how people think about AI systems that they use all the time. So here's Google Maps. I've asked for directions from this point to that point. And the last half of it, roughly, is a walking path. So take the tram to here and then hike yourself over there. What do you think is true about that path? I've asked for that path at noon. Would you recommend a different path at midnight? There are paths in San Francisco I would not walk on after 9 p.m. Just no way. You probably have places like that here. So what do you believe is true about the path that Google Maps generates? What properties adhere to it? Is it safe? Is it scenic? Is it fast? What you believe about the way the system works determines the way you use it. More importantly, can I ask for an explanation? We all know that AI explanations are the rage these days. They're in fact mandated by lots of regulatory and legislative bodies. How do I get an explanation for this? Maps is particularly problematic because I asked to go from Boise to Stanley. The next day, it sent me a different route. This was Tuesday, 3 hours. This is Wednesday, almost 4 hours. Why? I can't find out. So if you futz around, you can keep getting different answers depending on when you ask. So what happened actually here, I found out later, was that there were forest fires on the upper path. But I would have been handy to know that. If I'm going to drive an extra hour, I want to know that there's a reason. What about systems that look like AI? So in Google Mail, you've probably seen this. Pop-up says, looks like you forgot to attach a file. Anybody seen that before? Hugely successful, right? Magical experience. Is it AI? No, it's a regex. That's all it is, right? But it seems magical because it does exactly the right thing when triggered in exactly the right way. Do you care that it's not AI? So when we're designing with AI, I want to think briefly about what we should be doing and what we shouldn't be doing. So one of the things I want you to understand is that not all known problems are solvable by machine learning. So Han Solo has it right. We don't use ML to solve all known problems. So a better question for us as designers, as practitioners, is to think about, well, when does it make a difference? When do we want to turn the magic AI button on? So here's an example. You can make up a million examples, right? Go ahead and do it yourself. Here, I have an AI agent that emails on my behalf. It's John's niece's birthday. It's a busy day. The assistant knows John's busy, so it drafts an email and sends it to the niece. Everybody's happy. Question, do you want that? What could possibly go wrong? I don't know about you, but I get reminders from Facebook to please invite this person to be your friend, but they died last year. What could possibly go wrong? So I want you to think about this carefully because there's a kind of slippery slope on a lot of this stuff. So we saw this spelling correction. Kant gets corrected to Kant, and that's good. John Boyd gets corrected to John Boyd. That's good. What about this? Population of Japan is 110 million. Should it autocorrect to the correct number, 125.1 million? Is that okay? Whenever Dan says, is that okay, start to worry. Here's another question. The World Trade Center was destroyed by terrorists flying planes in the building. Should that be auto-corrected into, it was destroyed by a cabal of the government using explosives? See what's happening? We went from spell correction, where the spelling correction is clear and there's a canonical spelling, to concept correction. The last one was okay. This one, who gets to control concept correction? That's your big question. So does your mental model of spell correction include concept correction? Should it? Because it's clearly possible. So as you know, there are certain issues these days with language models. Hallucination is probably the best known. So in this case example, I asked which US president went to University of Wisconsin-Madison, and it gave me a bunch of answers, none of which are correct. Andrew Jackson did not actually graduate from UW in 2005, right? So that's a problem. Then I asked to write a short biography of me, because I could fact check that very easily, and I got half wrong. I have, in fact, never been to Waterloo, let alone started my career as a professor of computer science there. So this is standard hallucination, and it troubles me to say standard hallucination. This should not be a standard anything. And you probably saw this one. cheese not sticking to pizza, and the recommendation is to add 1/8 of a cup of non-toxic glue to the pizza sauce. It's not hard to find examples like this, and this bothers me a lot. That it's easy to find recommendations that you'd eat a rock a day, or you should add glue to your pizza sauce. So the fundamental question for a lot of HAI and UX design with AI is, how do we design these things? And how do we, as deliverers of this technology, do the right thing? I want to propose there's something about the way LLMs work that's really not skippable. So you might see this as a face, this inevitable response. You sort of see that, or maybe you see that as a face, or maybe you see that as a face. You see where this is going? There's even a term, pareidolia, which describes the non-conscious response to visual stimuli that makes you see a face, or an archangel in a tortilla, right? That happens. So what's interesting, I think, is to remember that this has been around. This has been known for quite a while. You may not remember ELIZA, but back in the 1970s, Joe Weizenbaum wrote this system called ELIZA, which is basically a chatbot. There's some pros. And once upon a time, back in the late 80s, when I was teaching AI, I would assign to my students, build me ELIZA. I'll tell you how it works. We do a lecture, I show you how it all works. You go off and you build ELIZA, and then you turn it in. Give me a couple pages of the interaction you had with it. My students were so taken with this that I got transcripts that went many, many, many pages, and I learned way too much about their personal lives. So I had to stop it, because the students, even though they built the system, got sucked up. They had this response that they really couldn't control. And so there's a whole literature around this, mostly started by Cliff Nass and Byron Reeves, but there's a whole literature around how people look at this stuff and they can't not see it as coherent, fluent, possibly correct. And so what happens is that our judgment of these things gets suspended. So remember this, which US president went to the University of Wisconsin? I would call this cybernetic mansplaining. That's exactly the right phrase for it. It's made up, but sounds very confident. And it's done by a machine. This becomes an issue when we count on our machines to do identifications for us. My cat is one thing, but what about these mushrooms? I will tell you, one of those mushrooms is toxic and will kill you. The other one is perfectly good to eat and tastes great. Are you going to trust your phone to tell you which one is right? Oh, maybe you want to use an app to do that. As Darren points out, survival bias means this app will only get great results. And you thought survival bias was a technical term in statistics. But you see the point. The point is, we find it very hard to not look at these things and sort of take them in. They look great. So my second observation here is that a cybernetic mansplainer needs epistemic humility. It needs to admit when it doesn't know something. And we don't really have the mechanism for doing that, at least not in our current models of AI. Language models don't have epistemic levels of understanding built in. They just create the next most probable token. For the next part, I want to talk about where this sits in our larger research culture, because we're off building AI systems and teaching large language classes, and we're doing all this great stuff, but we are embedded within a research culture, and I want to tell you a couple things real quick. Because it's one thing for us to understand the culture, but it's another thing for us to hack the culture, which we can do. You all are empowered to change our culture. So let me tell you a couple of memes and stories that we tell ourselves. And here's the first one, which is there's this myth of instant success. We develop a technology, we launch it into the world, and bang, it's there. Well, video conferencing is one of those that sort of gainsays that. 1960, there was the very first demo of video conferencing. Of course, 1968, you saw it in 2001. Remember 1960? We saw it actually working in 1968 in the mother of all demos with Doug Engelbart. But we, meaning you and I in universities, didn't get it until 1992 when we got See You, See Me. How many people saw and used See You, See Me? Anybody? Okay, the old guard. The rest of you, it was crappy Zoom. It was really, really poor quality. Then around 2000, we started getting really great quality stuff. This is from Cisco. And of course now, even though that was the model, that was the image of really great high quality video conferencing, what we live with is this, which looks exactly like this room, right? One projection, one guy. It's not quite what we were hoping for. So there's this notion that when you build a great technology, people will come and it will ship and it will be an instant success. I went to Xerox PARC, the University of Xerox PARC, and I learned about tech transfer. There's multiple books written about this, and basically the TLDR is it's harder than you think. So back in 1986, Alan Kay sketched this Dynabook idea, which is basically a tablet with, in his case, he put keys on it. And then in 1992, as Jim said, I went to Apple, and that was my office right there. And back in those days, we built a prototype with multi-touch screen, built-in Wi-Fi, built-in camera, whole 9 yards. This was the age of tablet computing. Everyone was trying to build one. We were all working on how to create one. The Newton was out about this time. It was rather small, kind of underpowered, anemic processor. And so we then left Apple, and we went to a startup called Uppercase, and we built one. Dang it. And at the time, we did a review with our overlords at Xerox, who said, why are you building a hardware? What's wrong with you? And so they sold us to Microsoft. And so we became the Microsoft tablet, which was shown at Comdex. And that's how technology transfer happens. So 2000, of course, then 2010, Steve very proudly stood up and held up the iPad, like, dude, you could have had this 15 years earlier. But tech transfer. We also have the myth of instant success with the Mac. Remember that, 1984? I know most of you were not alive, but that's okay. We were alive, we saw it. It was amazing. Oh yeah, Lisa came before the Mac, right? And before the Lisa was the Alto, which I first used in 1977. It took that long to get that form factor into the hands of regular people. So, as Jim suggested, I wrote this book a couple of years ago now, and the idea behind the book was really to give people an understanding of how to use this big, complicated AI system that we call Google Search. Because just because it's simple, it's not obvious how to use it effectively. So I've done a ton of research on this. I've done hundreds of field studies, walking people through various things. I've built a MOOC that's had 4.5 million people go through it. You know, I got a lot of data. And one of the things we discover in these classes is that people believe that this is the model of the world, that Google has every book, every video, everything. Not true, just so you know, right? So I asked a lot of people, around 1,000 people, to draw me a sketch of how Google works, okay? And that's done by a CS student. So it's kind of not bad, right? That's not normal. This is more normal. It says several overlapping concentric circles in nonlinear binary targets. I have no idea what that means. I'm willing to bet you that person doesn't know what it means either. This is word salad that they've heard. What's interesting about my 1,000 sketches of how Google works is that 33% of them have the word magic on them, which means I give up, I have no clue. It's all magic. So what do people do? To understand what people do, we employed a whole bunch of different kind of research things. And I want to talk for just a minute about what's acceptable in a research culture. So each of these types here, eye tracking data, surveys, A/B testing, and visualizations, were all acceptable or not acceptable at different times. When I first went to Google, Thou shalt not show me survey data. That's the devil's work. It's not real. It's just people expressing what they think is true. Well, we now have a different attitude, a more enlightened attitude. Eye tracking was a similar kind of thing. What is this? How can you actually determine anything? So let me talk to you a little bit about each of those. So eye tracking, back in 2004, we did this big study. We took an eye tracker to Walt Disney World. That was a trip in and of itself. We were there for a week and we ran 32 people doing a kind of study of how people actually read the search results page and how they looked at the ads. So the setup was something like this. We'd get a person, have them sit down and then use this eye tracker with no head attachment or anything, and it's great. Here's the first big result. There were a bunch of results, but this is the first one. So if you look here, this point here is where they start their eye fixation. This one's off the screen, same thing, they start up here. Nobody looked at the top ads, except for the non-sophisticated users. The novices totally looked at the first result, second result, third result, and so on. Advanced users would go to the bottom, skip over the ads, go to the bottom of the page, and then come back up. If you're an advertiser, you really want to know that. Right? We discovered also that people would say things like the top ads fake you out, whatever. But what was two things really interesting about this. First, I made a bunch of videos documenting what happened there, and I ended up, over the course of my career at Google, I made the equivalent of 4 full-length 2-hour movies. Nothing I've ever done, no publication has ever come to the effect of showing these short videos in engineering meetings. There's something about engineers watching a person on the screen yelling at their laptop, yelling at Google, "What have you done?" It's a gut punch. It's a really powerful, effective method. So the other thing we did is, in these studies, we actually gave people real money. Jim, here's $50. You can go spend it however you want. You just have to do a Google search to start. What we found was that the way people behave when they're given real money versus simulated money. Hey, pretend you have $50 and search for new brown shoes. Those are, let me see, apples and communism. They're totally non-comparable, complete non-comparable. So if you do a study of people doing purchasing behavior online and don't give them real money, throw out your results. It's a waste of my time. It's a waste of everybody's time if you don't actually give them real money. You're asking them to fake something that they can't fake. So don't do that. We also went through, as a research culture, maybe some of you have collectively helped do this. You created all these visualizations, which are wonderful. I used to do InfoViz as well, and there's a million of them out there. Here's one thing you have to know. When you present InfoViz like, say, this one, to a bunch of busy vice presidents and product managers in a corporate setting, they go, wait, what is that? It's too long. Next. You've lost them. So anytime you take an executive and have their eyes glaze over, you've wasted everybody's time. So I thought, well, that's interesting. What chart types do people really use at Google? So I did this study, and I ran around and got 1,500 examples. And here's the bar chart. Line graphs, histograms, tables, arc-node diagrams, pie charts. That's 85% of everything. All that other stuff, all that fancy stuff you do down here, it's in the noise. I thought, that's really weird. What makes a visualization a success? Is it just the uptake? So what's going on here? So I worked with graduate student Heidi Lam, who was at UBC at the time, and we built this really wonderful, rather she built it, I just advised, visualization of time series data, of log events, so called the session viewer. And it was brilliant. It's a Java application. You could actually see deeply into the data. And if you were a data analyst, this was your best friend. It had multiple panes. You could query it in 9 different ways. And then we deployed it. That's what happened. It sank without a ripple on the waters of Google. So a little bit later, Heidi came back and re-implemented it in JavaScript. We could run it as an app. It didn't have to load Java and get the wrong version of Java. Not that it ever happened, but we then integrated it with all the data sources and in the standard data analyst package. All of a sudden, used everywhere. Those charts start to appear in PM reports and so on. And people started to learn how to read those diagrams. We also threw out half of the functions. Half of the functions. Functions we thought were essential. They were not essential. We had to learn that. A couple years later, Kerry Rodden, who was at Google at the time, built this sunburst visualization, which you might have seen. And she did exactly the right thing. She also built it in JavaScript, integrated it into packages, widely used, big acceptance, very easy to learn. That's key. Your visualization has to be easy to learn by PMs. And I love PMs, but they don't have a lot of time. So it takes more than like 45 seconds, you've lost them. So that's a little bit about the culture. Let's think about where we're going. So the HAI future, right? None of this will surprise you. But we have to figure out how we manage all this stuff that's coming out. Will we have future courses on prompt engineering? Or will there be a new profession, robo-psychology? Susan Calvin was the robo-psychologist in the iRobot series of stories by Isaac Asimov. Is that a real profession? It's getting to be that, because you now see prompt recommendations. Be polite to your LLM. Ask for permission to please do this data analysis. Does that work? I leave it to you, students, to figure out. That's a recommendation. It's the psychology of LLMs. I never thought I'd say that sentence. We're building tools that have interesting novel interactions, like writing recommendation systems that highlight segments of your prose based on an LLM rewrite. Is that a great model? These kind of services have been around for a while. So this was Google Sheets as of like 5 years ago. And if you look in the bottom right, those are recommendations for visualizations of the data set that's in the sheet. This has been around. These kind of co-pilot service things that live with you in the data, live with you in your computational world. Where's the future? We all know from the last Chi that if you give someone an LLM, all of a sudden their creativity scores go to 100%. It was a remarkable series of papers at Chi to see how much creativity is enhanced by using a language model. But interesting question, is that a Vermeer work? Or more importantly, how can style be abstracted and exported as a thing? Because now you can say, oh, Botticelli, it's just a style. Picasso, just a style. Lichtenstein, it's just a style. We can abstract that, and that becomes something to be applied, like red paint. In particular now, when you think about music generation systems, you can get an infinite amount of Bach by clicking the Bach faucet. Or my very favorite example is, this is a little piece of emo rock done by Suno, and the prompt was, Dan and Peter teach an AI class at Stanford. Write a song in the emo rock style of them teaching that class. And this is what happens.
Peter and Dan teaching AI at Stanford, where hearts turn to ice, robots learn to feel machines.
I don't know about you.
Alive.
That's Dan impression.
World where humans strive.
It goes on. The thing that's so surprising about it to me is it did the lyrics, it did the music, and it as a tag chorus at the end, which I did not expect. And it's all coherent. It's not the best prose in the world, but I've heard a lot of garage bands do much worse. What is creativity in that context? We as HCI people have a lot of responsibility here, both for understanding what copyright is, what ethics are in data collection and reinforcement learning, how human tagging. But I want to elevate this conversation one more step. I want you to be thinking about our obligations for ecosystem design. Because here's an example. tell me how I can make chicken parmesan, and it gives you the recipe. Why would you ever click on those links at the top? How does that change the ecology of the web if you never click through to the destination? If you're a creator, how much are you motivated now knowing that the search engines can pull out all your content and redisplay it? It changes the ecosystem. I want you to think about this because as designers, as UX people, we also want to think about things like this, where this is downtown Los Gatos, a little town near where I live, where Google Maps routes thousands of cars through there every busy weekend. The police there have taken to Google and marked some of the roads as closed. They're not closed. They're really not closed. They fake it. Or, in an even better example, Simon Veckert takes 99 cell phones in a little red wagon and walks down the street. Google picks that up and says, oh yeah, really busy, don't go that way. So people are spoofing traffic flows in order to hack the culture. You, the future designers of our AI landscape, need to be thinking about this. Smart thermostats, great idea. AI thermostats like the Google Nest thermostat, marvelous, except we know as HCI people, nobody changes the defaults. So all the Nest thermometers in the world default to power on at 6 a.m. and you can see the spike in the power load. That's the green line. Oh, I didn't think about the ecosystem of HCI AI that I'm building. So what I want you to think about is to design not just for your favorite application, but for the entire ecosystem. Your AI system can change the world, maybe not in the way you expect it. So let me wrap up by pointing out that, the UX of these AI systems is absolutely critical. We need to understand how people think about them. What do they think about the Google Map routing that they take? How can we do all of that? And how can we think about not just building smart AI systems that get us a lot of money or increase our stock price, but actually make everything a better place to be? We also have to think about the ecology, the ecosystems of the world that we're inhabiting, so not all cars are directed right down the middle of Main Street, Los Gatos. Thanks very much.
So we have time for questions?
I was curious about explanations. I have an intuition that we never really need an explanation, that it's something else that we usually want. For example, with your fires in Idaho, I don't per se need an explanation of why it's routing me around. I'm curious for, I don't know what exactly, but it somehow feels like explanation isn't quite right. And I was curious if you had a take.
Yeah, no, explanations are genuinely hard. Partly because the way I think about explanations, it's an interpersonal act. An explanation is generated to help you understand something. And so your explanation for that particular routing problem is not that some neural node layer went to 100. You actually want to know about the fire. That's all you need to know. So it's a very simple explanation. Or maybe it's just a story. But an explanation is intended to achieve a particular result in the hearer. They're also required by legislation. So if you are, for example, turned down a loan or you're put into jail because of an AI system choice, you get to have a story about why that happened. And the explanation is not going to be at the level of the neurons in the neural net. It has to be a more functional explanation. The second thing about that is that it has to be in the right register, right? Giving a very technical explanation about why someone was denied bail in terms of the legal code is not going to work for most people who are denied bail. You need to figure out what the language is and the concepts are that they have and express it in those terms so that they can understand what's going on. So I think it's very complicated, and it's a great research topic. Students, just saying, there's a lot of work needs to be done in this area.
Other questions?
You're going to have to run, Jim.
Yeah, you talked about the AI knowing like mental models, what you know. There's one thing that to understand something, but also to remember it. Perhaps it trying to teach you based on how you learned before or the stuff that you learned before.
Right.
How would you keep track of what they're remembering?
Right. So the mental models, or rather the user models I was showing you earlier, had an explicit breakout of all the concepts that were important for, say, for fundamental math and arithmetic. And so you basically, mental models, user models, keep track by just basically checking it off. Dung, dung, dung. Smart models also track how often that skill is used and how often it's not used. So if I checked off knows the quadratic equation in 1992, you might want to fade that out because nobody remembers it for more than 10 years. And that's being generous. So I think that's the kind of tracking you need to do. And a user model is not the same as a context window, right? The context windows may be 1 million tokens long, and that will capture a lot of the previous, say, couple days worth of interaction. But it doesn't remember what you did last week, or last year, or God forbid, 5 years ago, right? Or that you were once upon a time an expert at jujitsu. I don't know. Other questions? You get to toss the microphone to somebody.
Thanks for the talk. So my question was for the last part where we are building our solutions, keeping the ecosystem in mind.
Yeah.
So in that example where the road was blocked in that street, if a designer wants to come up with a solution, the designer must have all the abstractions of that ecosystem first hand, and then it could come up with a good solution. But right now, our ecosystem, our system designing is so messed up that we don't have interrelated abstractions which we can work on. It's basically like endpoints, but not from API, but from our ecosystems. So we don't have those endpoints to work on. And that's why when we build these systems, they just snowballs and destroy and disrupts other subsystems. So how do we reduce this wickedness as designers?
So a couple thoughts about that. First, if you never look, you'll never discover. So take a look. Some of these are not that hard to predict ahead of time. The thermostat, for example, you should have known that before you deployed 1 million thermostats. And you knew it was going to be a big hit on the power grid. That's easy to predict. But to your point, a lot of these things are things that you legitimately did not know ahead of time, and you have to figure it out. Pay attention to the customer hotline, and a lot of companies don't. And they just blow that stuff off, like, we don't need that. I think it was Henry Ford that said his best research department was the complaints that he got. And I think that's probably true here. So I think these companies should have a very active and proactive way of responding to issues as they arise.
Hello. I also wanted to ask a question about the ecosystem. You said how AI can take the stuff from the source and just spill it out, and you'll never see the source. But I wanted to say, like, how do you feel about Wikipedia? Because that's like kind of already been established. So like, is this like a really big leap, or is this like a different way of looking at it? Yeah.
Well, a couple things about Wikipedia. First off, the quality is really very, very good at Wikipedia. There's been a kind of, in the US, there's been the common teacher trope, Wikipedia is terrible, anybody can edit it. To which I say, have you edited Wikipedia recently? No. How many people have edited some entry in Wikipedia? Okay, that's less than 10% of you, right? And it's tricky, right? You can't just do it. So it's much higher quality than, and there's been a lot of studies showing it's actually quite high. Every language model I know about has been trained on all of Wikipedia. I have no idea if Wikipedia is okay with that or not, but whatever. But it's worth thinking that Wikipedia became the basis for a lot of knowledge graphs that are out there. It's not perfect, but the accuracy is higher than almost anything else you can think of. Okay? Yeah. Sir.
Dan, So that was a great fun. Thank you so much for just a lovely, thoughtful, but also entertaining. Here's the question. Why did Jones go down Main Street at 60 on Saturday night? And this is about the pragmatics of explanation, but I'm going to tie it to the richness of input relative to context. So here's the top question. You have a certain input size, expressive power of the input. If you know a whole lot about the person, you can make a whole extra assumptions about that input and draw a lot of inferences that aren't present by adding extra axioms of a certain sort, we might say, mental models and so on. Right. So that's but then there's this thing. That input still has a certain size. So I say to you, why did Jones go down Main Street at 60 on Saturday night? And the answer depends on whether I said, why did Jones go down Main Street on Saturday at 6? Because normally it's Smith. So the reference class against which I was asking this question was Jones. Why did Jones go down Main Street? They normally go down Lake Street. Why was it Main Street that they went down? At 60, it's usually 80. On Saturday, normally it's Sunday. So depending upon where the reference class is, which isn't available except through the intonation structure of the sentence, but you don't give me an intonation, whatever we take as the input, there's a greater opportunity for richness than we're normally given. If this was typed in, I can't possibly do it.
Right.
So how do you deal, this is a fundamental issue, right? There you have an input size.
Right.
It's got a content. That content is multiply ambiguous in many ways. We can shave some of it down by a user model. We don't know all about the real context in which it's taking in addition to the user model. And there's some fundamental relationship between the thinness of the content and the need for an answer.
So many things to respond to.
Of course.
First off, an observation. Remember when speech recognition used to be an AI problem? Now it's just an API call, right? So what we think of as AI changes over time. AI is just what is currently hot and topic and bothered. You used to be able to get a PhD by writing a chess playing program back way long time ago. And so what we think of as AI shifts over time. Speech recognition is particularly interesting because I can see a time when you're not just going to get the transcript, but also the intonation. You'll get the prosody, at which point now you can start to answer some of your referent questions by looking at the prosodic information that comes along with the text, right? So it's coming, trust me. So that kind of thing, but then, no, you've got a rejoinder. Do you have a microphone? What's your rejoinder? Now you broke it. Thank you, Jim.
It seems to be that.
Yeah.
The rejoinder is, the comment I'm making is, whatever size input you take, there is some relationship. It's the invariant. So you cranked up the input now to include intonation structure, which is exactly what I wanted you to do with respect to that question. But it happened to have been intonation structure. But if it's not intonation, there'll be something else.
No, I completely understand that, yeah. So it could be, for example, the background knowledge. You were saying Jones always goes on Saturday, not whatever, right? And so, yeah, there's always more that one could know. I think any inferring system, including people and dogs and AI systems, work on the basis of the knowledge they have. And they do the best with what they've got. And so you could always know more. So I think you kind of do the best with what you got. And I would argue that a lot of what our inferring agents do now is very, very tiny. We can do better. We can do better. Okay. You need a microphone.
Okay, yeah. I had a short question, so I'll make it quick. How do you elevate salient ethical concerns within this design, and how do you do that in an actionable way, recognizing that oftentimes, if it isn't actionable, executives will shelve AI trust and safety in favor of progress. So how do you actionably elevate in the very design itself ethical concerns, which you mentioned so much at the end of your presentation?
Yep. So you're asking, let me rephrase your question. What can we actually practically do to ensure ethics and, for example, accuracy in the systems, right?
Yeah.
Okay. So this is a still open question. I mean, what you see companies doing is trying to do better and better training on higher quality content in an effort to make it both more accurate, and then providing guardrails, which are essentially fancy meta prompts, in order to ensure that certain kinds of bad responses don't come back. For instance, one of the things you'll see that the pizza example I gave now no longer works because somebody at some company put in on a block list saying, if you get asked about pizza and glue or sticky pizza, whatever it was, don't answer it, right? Just give the organic search results. So basically, whenever you see those things coming up on Twitter, whatever it's called, there's somebody typing in, block this kind of query. And so, but that's not a way to do it. It's just sort of a tactical move. The deeper ethical issue also extends back towards who's labeling data, how is that data collected, and that's a topic for another talk.
Okay, let's thank Dan.
Great, thank you.
He'll stay around for this and chat.